Hello, this is Professor Jen-Mei Chen at Cal State Long Beach. In this example, I will illustrate to you a business application using multivariable chain rule. The number of organic peanut butter jars depends on the price of the organic peanut butter and the non-organic peanut butter at any given time. We're interested in knowing how the number of organic peanut butter jars changes with respect to the time 6 months from now. So notice that, first of all, that Q, which is the number of jars of organic peanut butter, depends on the price of organic and non-organic peanut butters, which are X and Y with respect to each other. And each of those organic and non-organic peanut butter jars prices depends on the time, which is T. So we're looking at this tree diagram where Q is on top, which then depends on X and Y. Both X and Y are depending on the variable T. It's always a good idea to actually put in the units next to the variable to keep in mind the final units. So Q is in terms of jars, both X and the Y are in terms of the dollar amounts, and the T is in terms of months. The question is really asking you the rate of change with respect to time of the number of organic peanut butter. So that's really asking you to find dq dt when t is equal to 6 months from now. So in order to actually find dq dt, we have to factor through the two branches of the tree diagram. So the left branch, you have q sub x times the dx dt. On the right branch, you have q sub y, or dq dy, times dy dt. For q sub x and q sub y, because they are partial derivatives, since q is a function of two variables, that's why we use the partial notations. For x and the y with respect to the time t, because both x and y are only functions of the single variable t, therefore we use the traditional notation of dx dt or dy dt. So with the tree diagram, we can write down the following. The dq dt is equal to the first left branch, which is q sub x times dx dt, plus the right branch, which is q sub y times dy dt. If you now go back to your functions and grab each of those appropriate expressions, for q sub x, you go back to the function q and take the partial with respect to x. The 170 becomes 0. For the second term, you get negative 50 times 2 times x, which is altogether 100x. For the third term, you get 6 times y. Remember, y is the constant in a partial derivative calculation. For dx dt, you go back to the function of x of t and take the differential of, take the derivative of that with respect to t. You simply just get 0.5. Similarly, you do the same thing for q sub y and dy dt when we get the following. Now the question is, what is x and y and t? Well, what we could figure out at this point is that when t is equal to 6, we could try to find out what x of 6 is and also y of 6 is. Because then, if we do that, then these two becomes number and it will be easily calculated from then on. So we're going to go back to x and the y and try to figure out what happens when t is equal to 6. So when t is equal to 6, x of 6 is equal to 6 plus 0.5 times 6, which is altogether gives you a 9. Similarly, you can find out what y of 6 equal to, which is 16. Now that we have the specifics, we can go back and plug in what dq dt should be. So plug in x equals 9 and y equals 16 and t is equal to 6 everywhere in the dq dt expressions. You simplify this a little bit using calculator, we get negative 271.8. Now to explain what that means, because this is a rate function, right? So make sure that your unit is a rate unit. Because it's dq dt, so we're going to take the unit for q over the unit for t. And that is why the answer is that the monthly demand for the organic peanut butter will decrease by 271.8 jars per month. And remember, that's decreasing because the negative sign in your final answer. This concludes this problem.